Welcome to Let's Talk Micro. Hello, everyone. Welcome to another episode of Let's Talk Micro. As always, I hope you had a great week. And you can always find Let's Talk Micro on Apple Podcasts, Spotify, Amazon Music, Google Podcasts, Stitcher, TuneIn Radio, Pandora, GoodPods. Wherever you listen to podcasts, you can find Let's Talk Micro. As for our social media, I am on Instagram as Let's Talk Micro, no apostrophe, on Twitter as Let's Talk Micro 1, on LinkedIn as Luis Plaza, and on TikTok as Let's Talk Micro. So please go ahead and subscribe to the podcast, download episodes, leave a review if your app allows you to do so, and of course, follow on social media. Leave any feedback, any suggestions. If you have any topics, you can go ahead and leave them on social media, or also send me an email at letstalkmicro@outlook.com. Any feedback, any suggestions, they are always welcome and appreciated. As always, thank you for listening. And if you haven't listened to the previous episode, please go ahead and do so, because this episode right now, it's part 2 on a series. So the previous episode was part 1 about discrepancies we know between genotypic and phenotypic testing, specifically with blood cultures and antimicrobial susceptibility testing. Those of you that work in microbiology and work with blood cultures, you know that you have instruments that will provide an ID, and they also can detect some genes that confer resistance. So what do you do when your printout, gives you X organism detected with X gene detected, and then you set up your susceptibilities and they don't match? For example, right, mec-A detected with a Staph aureus, and then when you set it up, your susceptibilities, your oxacillin is susceptible. So what do you do? So in the previous episode, Dr. Rachael Liesman from the Medical College in Wisconsin, she went ahead and started breaking the terms. She talked about what's the phenotypic testing, what's genotypic testing. She talked about mec-A. She also gave some basic steps in troubleshooting. And on this episode, she's going to give specific examples of discrepancies. So definitely, if you haven't checked out that episode, go ahead and do so. It was great. And I hope you enjoyed this one. So let's go ahead and listen to it. So I know, in the presentation that I attended, you mentioned, some case studies and along with their resolutions. So can we go through some of these?
Yeah, I'd love to do some case-based approach. Do you want me just to start and pick a case?
Yes, please.
All right, so let's start on the gram-positive side, and probably the most common. I figure we can go through the most common type of discrepancy that I have experienced in using these panels. So typical gram-positive discrepancy is going to be our MRSA-MSSA discrepancy. So in this case, let's start off with our bottle and our gram stain. That's what we're going to get first. Bottle goes positive, tech pulls the bottle, gram stain shows beautiful gram-positive cocci resembling Staphylococci. That gets reported in critical call, and we set up our BCAD. The BCAD reports a Staph aureus is detected and reports detection of the mec-A gene. So what we're predicting here is an MRSA, and that gets reported, and the clinicians are going to be treating the patient as if they have an MRSA bacteremia. So we culture from the bottle, so that subculture grows up. Day 1, throw that on the moldy Staph aureus. Perfect. We have concordance between our identification. Good to go. We then set up our phenotypic susceptibility testing, and our phenotypic susceptibility testing reveals the isolate to be oxacillin susceptible. So now we've got a discrepancy between a mec-A detected and an oxacillin susceptible isolate. So that's kind of where we need to do some troubleshooting. So first, we're going to go back to the basics, right? Make sure your reports are correct. Make sure there's a specimen or bottle mix up. Double check that purity plate. For Staph, there are different breakpoints for Staph epi versus aureus. So double check and make sure you're using the right breakpoints and you've got the right interpretation applied. All right, so we're all good to go there. The next thing I'm thinking about are, what are the reasons I might see this discrepancy? And that's going to guide then what I'm going to do as far as workup goes. So the most common reason we see this MRSA-MSSA discrepancy is actually that there is a coag negative Staph buried in that bottle somewhere. right? So some of the panels have Staph epidermidis as a target, but not all of them do. And then almost none of the panels have the other coag-negative staph, so Staph capitis or Staph hominis, right? And we know that we see coag-negative staphs in blood culture bottles as contaminants, not infrequently. So it could be in there, even though there's a Staph aureus in there. And then we also know that the coag-negative staphs carry mec-A at a much higher rate than Staph aureus. And so if you have a coag-negative staph in there, it is statistically more likely that that is carrying the mec-A than your Staph aureus. So that's kind of number one for me. It says I'm going to go dig around and see if I can't find a coag-negative staph, and I'll talk a little bit about how we're going to do that. The second possibility is you have a heteroresistant population of Staph aureus. So by that, I mean, it's a mixture of MRSA and MSSA. So everything in the blood is a Staph aureus, but some of it's MRSA and some of it's MSA. And when you did your genotypic, those were really sensitive. So it grabbed that mec-A, it detected it. But your phenotypic, you know, mostly the colonies you're grabbed are the MSSA. And so that's maybe where a discrepancy is. And then the final sort of more rare thing that might be happening is you have a mutation in the gene. That means the gene can still be detected. It's not kind of where your primers are for whatever assay you're using, but that the gene is not making a functional protein for one reason or the other, right? So either there isn't protein being made at all, or it's making protein, but the enzymatic activity is not functional for one reason or the other. So you have the gene there, but it's not expressed appropriately, and that's how you end up with oxacillin susceptibility. So those are kind of the big things I'm thinking about in this particular case. So the next question is, how do we go hunt for this, right? Like, how do we figure this out? So the first thing I'm going to do is I'm going to go back to that primary plate that was a subculture and look really, really, really hard for a second morphology. And most of the time, this is actually where we work this out. There is a tiny bit of coag-negative staph. It's buried in there, but you go and you find that colony. It looks a little bit different than your Staph aureus. Pick that out. Staph epi or hominis or something, that's your mec-A carrier. So that's the first thing. If you find that, you're good to go. You can perform your susceptibility on that coag-negative staph. I usually revise your result on your BCID to sort of make it so that not telling the clinician that's an MRSA, call the doc, let them know, MSSA, explain the kind of situation. So that's a quick resolution. Doesn't always work out that way. The other thing you can do is you can go back to your blood culture bottle and you can subculture to a plate again. And we usually do what we call a heavy sub. So you're just putting more of the bottle onto the plate, increasing the likelihood that you find some low amount of coag-negative staph. And then one of the things you can do with that is you can actually drop a sulfoxetine disc right in Q1 of your 4-quadrant streak. And so what you're looking is, you're not going to report anything off this, right? This is not like a reportable disc diameter, but what you're looking for is that Staph aureus, if it's truly oxacillin susceptible, is going to have a wide zone. And if there's an oxacillin resistant anything in there, Staph aureus or coag-negative staph, it's going to grow up to that disc. And you can pick colonies out of that sort of inner zone and subculture those and work those up. And that's one way you can go find that mec-A producer somewhere in there. So we're going to do that. That's obviously going to take 24 hours. So that adds a little bit of time kind of in there, but that's going to help us potentially isolate that heteroresistant population, potentially find that coag-negative staph that may or may not be buried in there. Some other things I might consider doing, again, we've talked about if you have an alternative method for searching for mec-A, I might go, retest the bottle with a different mec-A molecular method. I'm probably going to do a pt.2 test if I have that in my laboratory on those Staph aureus isolates, just to make sure. I'm probably going to reset that Staph aureus up for phenotypic susceptibility testing using an alternative method. So I might reset my panel, but I'm also probably going to set up a sulfoxetine disc or something like that. So using a different method, just double checking that phenotypic kind of result for that. So those are the things that I would do to try to troubleshoot this particular scenario. At the end of the day, if you're lucky, you find that coag-negative staph and you report that out and you have an MSSA and you've got this coag-negative staph, probably a contaminant, don't really need to worry about it. If you can't find that, the guidelines essentially say to report that isolate as an MRSA, even though phenotypically it's susceptible. So this comes from the CLSI M100 document, which essentially says if you have an isolate that's positive for mec-A, or it is positive by pp.2 testing, or it is phenotypically resistant. So any one of those can be true. Report that out as a methicillin-resistant Staph aureus, even if there's a discrepancy, because you just don't know, and you want to err on the side of caution in that case of saying this is an MRSA. So I would do that. The other thing you want to kind of keep an eye on if you end up doing this, so if you have an isolate that is mec-A detected, oxacillin susceptible, that you end up reporting as an MRSA, you want to check and see if that isolate's anywhere else in your lab, right? So let's say this is coming out of blood, but the patient actually had it in their urine too. So your urine culture bench has already found that Staph aureus and probably performed susceptibility. And because they're only performing phenotypic, they've already reported that isolate out as an MSSA. So now when your clinicians are reading it, they've got an MSSA in urine and an MRSA in blood, and they're going to be like, oh, what's going on here? Which one do I believe, right? And so the value of kind of doing that last bit of double checking is then you pick up the phone, you call the clinician, you explain what's going on, and you might even consider going and reporting that urine isolate or that respiratory isolate as an MRSA too. And so it gets really complicated when you can't really work out that discrepancy because you've got this isolate elsewhere where you're only doing that phenotypic testing. But this can help guide your clinicians and make sure that they understand that this is, that we're going to consider this an MRSA in the laboratory. So that's kind of, it gets real complicated, but that's sort of how I would approach our typical type of MRSA, MSSA kind of discrepancy there on the gram-positive side. Similar general rules apply for VanA and Enterococci. So general kind of approach and everything there as well.
Okay, yes. Yeah, I'm definitely, as you were telling me all this, like I was just thinking about it when I've seen it on the paper, and so many things like you mentioned with the urine versus the blood, and we definitely do this, as we are, even when we're setting, before we settle susceptibilities, we typically check the history.
Mm-hmm.
And that's one thing, it's also very helpful when we see something, that's very resistant. And then, we kind of checking, purity plate is pure. And then, but we see, oh, okay, well, this patient does have a history of this organism being this resistant. So it
Yeah.
kind of, we check those things. So we're reporting it as a MRSA, but at that point in time, you're not reporting the MIC, you're just reporting it as resistant.
Yeah, so this is going to differ lab to lab. My personal preference is that you hide your MIC, right? Because physicians sometimes look at that MIC, and if you have an MIC of less than or equal to whatever 0.25 and you call it resistant, some of your astute physicians are going to look at that and be like, "Oh, this doesn't make sense," and you don't want them to ignore your interpretation and go by the MIC only. And so we try to hide, we usually hide or remove those MICs from the medical record. So then they just can't see them. All I get is our interp. And so there's no conflicting information. Not every laboratory has that capability. And so if you do not have that capability, then you might consider adding a comment in there, or you might consider putting a comment in the medical record if you have that ability. You definitely want to communicate face-to-face with the clinician, but you always have to remember, and this is especially true at academic hospitals if you work there, that the clinician you're talking to today isn't necessarily the one that is caring for the patient tomorrow. And so that face-to-face communication or that one-to-one communication is important, but it's not the end of the communication when you're doing things like flipping results or hiding MICs or something like that. But yeah, you definitely want to address in whatever way makes sense for your system and your LAS and EMR limitations, the fact that you might have something called resistance with an MIC that looks very susceptible.
Okay. Yeah. And as you were talking about the coagulase negative staph, definitely I have seen those reports where sometimes, you get Staph aureus detected, Staph epidermidis detected, mec-A detected, and then it turns out that the one that's resistant is the Staph epidermidis and not the Staph aureus.
Yeah. Really typical. And that helps, right? So a lot of the panels now have that Staph epi on there. That's our most common contaminant. And so if you have that there, then that helps you out, right? Because it's not a discrepancy. And we usually put a comment in that essentially says, if you have two staphylococci that are detected, you cannot link genetically at this time the mec-A to either the Staph aureus or the Staph epi. So when we report the BCID, have a comment in there that says, I don't know who owns this mec-A, you're just going to have to wait for phenotypic testing. I mean, it's a little nicer than that, but that's the gist of the comment, right? And so I think if you have a panel that's going to call both of those, you want to have some comment like it. Where you get into challenges is when it's a non-epi coag-negative staph, right? So most of our contaminants are Staph epi, but we see a lot of contaminants that are Staph capitis or Staph hominis or something like that. And those are not detected by any of our panels. So that's when it gets really challenging, because that's when you're going to have that discrepancy that by the BCAD it looks like an MRSA, but when it comes out in culture, oh shoot, I've got a coag-negative staph in here.
Okay, so now, and you said, this kind of applies to when you enter a caucus. And so let's go ahead and talk about some gram-negative cases.
Yeah, so the gram negatives, if you can believe it, are even more complicated. Sort of. So gram-negative resistance is quite a bit more complicated. But from a troubleshooting perspective, you don't have to troubleshoot as many of these as you do on the gram-positive side. So with Staph aureus, if we detect mec-A, we can infer that it is MRSA. And if we do not detect mec-A, we can infer that it is MSSA, right? So the detection and not detection are both informative in the case of Staph aureus. And this is true of your Enterococci with VanA and VanB as well. If you think about the Enterobacterales, and we kind of focus on them, but this applies to Pseudomonas aeruginosa, which can carry some of these resistance markers as well. But if you think about the Enterobacterales, we really don't have as much actionable information that's coming out of these panels. So let's use CTXM as an example. If you have an Enterobacter cloacae or an E. coli or Club pneuma or whatever, and you have detection of CTXM, you can infer that that isolate is an ESBL producer. And so normally the antibiotic we're checking is your third generation cephalosporin of choice. So ceftazidime, ceftriaxone, whichever. The flip side of that note is not always true though, right? So if you do not detect CTXM, you don't necessarily know that your third generation cephalosporins are going to be susceptible. So that susceptibility is not predictive, even though the resistance is predictive. And the reason behind that is that the gram negatives have much more complicated mechanisms of resistance. So we think about our Enterobacterales, there's hundreds and hundreds of ESBLs. So we detect CTXM, but we don't detect any of the other ESBLs. It might be a different ESBL. If we think about Enterobacter cloacae, most Enterobacter cloacae are developing resistance to third generation cephalosporins by means of a de-repressed AMP-C. So that's a different beta-lactamase, but isn't on any of our panels. And so in this case, when you don't see detection of that AMR, it doesn't really predict anything for you. And so in our lab, we don't actually troubleshoot any of that. So if you have an Enterobacter cloacae detected on BCID, CTXM is not detected. And then when you set up your subculture, you grow Enterobacter cloacae, it's identified great on the MALDI. And then when you do the resistance testing, phenotypic resistance testing, you end up with ceftriaxone resistant. We don't do anything with that. That makes complete sense because it's probably an AMC. So the lab releases that, there's no troubleshooting. We actually, when we were doing this at my old hospital, didn't even report that CTXM was not detected because it's not actionable for most cases for the clinicians. So in that case, you kind of have to decide on the gram negative side what you're going to troubleshoot and what you're not going to troubleshoot. It's similar with your carbapenems. There are mechanisms for developing resistance to carbapenem antibiotics that are not carbapenemase genes, right? So if you have an Enterobacter cloacae and it's resistant to ertapenem, but you didn't detect any of your carbapenemase genes, KPC or NDM or any of the others on there, that's not necessarily a discrepancy, not something that I would troubleshoot. And so again, in thinking about what you want to flag in your SOP and in your LIS, we just let these go out because biologically they make sense and there's not any discrepancy testing that needs to be done. Whereas the opposite, so if you have an ESBL, if you have CTXM detected and you have ceftriaxone susceptible, then you would want to do discrepancy testing there, right? And so the approach is not actually dissimilar to what we did with MRSA. You're gonna, repeat your AST using a different method if you can. You're going to make sure that you don't have another organism in there, that your susceptibility testing was pure. Those are kind of your basics there. And if you can't find any explanation, you report it essentially as an ESBL. So you sort of defer to that genetic detection of the gene there rather than your phenotypic.
And when you're doing that, you're also, so then you're changing the interpretations of the, yeah.
Yep. Yep. So we would flip those third generation cephalosporins, and if possible, we drop the MIC, and if not possible, we'd put in a comment or do an explanation for why you had that MIC and interpretation discrepancy in your medical record. Yep. Yeah. And I just, kind of a note, the diversity of methods by which these gram-negative organisms develop resistance really limits the utility of these panels on the gram-negative side. And so there are lots of labs who elected to not even perform these panels on the gram-negatives because they just don't have the power that you see on the gram-positive side. And it's related to the fact that, okay, you detect the gene, it's resistant, but if you don't detect it, that susceptibility is not predictable. And that then really kind of limits the clinical actionable data out of the gram-negative side. And your bang for your buck on the gram-negative side just is a little bit different than on the gram-positive side. So you might work in a lab, or, some of your listeners might work in a lab where you only do the gram-positives, you don't do the gram-negatives, and that's why, because that gram-negative has some challenges to it.
Okay. And so, and just going back a little bit, I know that you talked about heteroresistant, and that's definitely something, yeah, that some techs, if you're listening, you definitely have experienced that. Like we have seen it in, like I've seen it, for example, like on a wound culture, and just even in the same plate, right? So you have two different, they look, like Staph aureus, and you do your latex, and it's positive, but they look a little bit different, and you kind of just do the testing on both just to see, kind of compare, and then you do get those cases when one is MRSA and one is MSSA on the same plate.
Yeah, definitely. And you get lucky if they morphologically are a little bit different, and that's why we want to pick those and work them up. But sometimes we probably miss them on something like a wound or a respiratory, because if they're not morphologically different, there's no way you would know. And so there's probably some undetected kind of populations in there that as we do a little bit more genotypic testing, we might start finding and having to kind of deal with in the clinical lab a little bit differently than before when we were just doing phenotypic only.
Okay. Any other cases? So that kind of just sums it all up for the troubleshooting.
Yeah, I mean, I think that's the big picture. Certainly it can get really complicated as you're working through these case by case, but I think those two cases were a pretty good overall gist of how I approach these types of cases and how we have developed protocols around troubleshooting these types of discrepancies.
Okay, and I like the fact that you mentioned, like there are many ESBLs out there, and there are many, like the same thing with the carbapenemase. It's like you do have a lot. I remember when I validated a test, and I got some samples. This was years ago, but I remember I got some samples from the CDC, and you do have like many, like OXA, many VIM, and many KPC. So it's just like you test for those. Typically, you test for those five, but that's not all there is. So it's always good for the for the listeners to know that. And
Yeah, and that doesn't even touch on when you combine resistance, right? So when you have, maybe a beta-lactam plus a porin mutation or a beta-lactam plus an efflux pump, and resistance in gram-negatives is very complicated and very cool. And our ability to detect these mechanisms in the clinical laboratory is very, very limited. So hopefully, as we all continue to practice, we'll see some new and exciting mechanisms or methods for detecting some of these mechanisms come into play, because it's a lot more complicated than some of these single target genetic testing is able to accommodate at this time.
Okay. Is there anything else that you want to add?
I think probably the only thing I would also point out is I love to always know where my resources are, right? So hopefully your listeners might listen to this and might remember, oh, shoot, troubleshooting, and they kind of know some of it, but they can't find it. So just wanted to point out the helpful resources. All of this information and so much more information is in the CLSI M100 document. So if you're unaware of that, that is the standards document for susceptibility testing. That's where most places are going to get all of their interps and everything. It is available for free on the CLSI website, clsi.org. Appendix H is a section called Using Molecular Assays for Resistance Detection. And all of this information is in Appendix H, which is at the tail end of the document. And so that's really useful if you're working on a specific case, but also really useful if you're trying to edit some of your protocols or policies to accommodate some of this troubleshooting. So I would encourage people to use that resource. And then there was a really nice paper in the Journal of Clinical Microbiology in 2021. Patricia Simner was the last author on that one. I think it was called The Genotypic to Phenotypic Dilemma, How Laboratories Should Approach Discordant Susceptibility Testing Results. And that was also a really nice paper that went through some of the most common scenarios we talked about here and some more. And then I think there's an algorithm in that paper that gives some labs some actionable information for how they would approach these. So I would encourage listeners to maybe seek these out, maybe bookmark them, look at them so that when they run into this or if they're working on a protocol, they can add that information into.
Yeah, I love how you mentioned this ELSI, and I definitely have mentioned this in the podcast many times. And you mentioned you can find it free online, and that's something that it just I encourage because normally in your lab you do have one binder, and sometimes I see people getting up and going back and forth, and this is one of those things you can put it on your favorites, and when you start your day, right, you're opening your instrument, you get that, and then so much information, and definitely you text out there, you should get familiar with it, a lot of information from intrinsic resistance and other things. So definitely that's a resource that we need to get familiarized with.
Yeah, I mean, been doing this for a while, and I still come across something in the M100 that I didn't know was in there occasionally. So it's there's so much useful information in that document, and I agree. I would encourage techs to start getting used to what it looks like, what kind of information in there, because when you're in a pinch from any type of susceptibility, including just your phenotypic susceptibility, there's a lot of good tips and tricks in that document that'll help you out.
And I will try to find that. I will find that paper and put it on the show notes for the listeners if they want to check them out.
Yeah, I'll email you the PM ID and a link so that you can get that pretty easy. Yeah, for sure.
All right. Thank you so much. Before we leave, one this is just a curious fact and that I wasn't aware of. But like I had some guests from the UK before on the podcast, and they pronounce cephalosporins cephalosporins with a K.
Yeah, I have heard that cefazolin is another one that people pronounce differently. Yeah, there's a lot of different pronunciations even within the field in the US, but definitely there's some across the pond differences in how we pronounce some of these drug names. And if you don't hear it very often, the first time you hear it, it throws you for a loop a little bit. So yeah.
Yeah, they stuck on my head for a while, and every now and then I'm reading a susceptibility report, and I go like cefepime, ceftazidime, and it was definitely something new.
Yeah, it's fun to know that and to kind of listen for it if you're listening to a speaker who is not from the US, every once in a while they use that. It's fun to hear.
Well, Dr. Liesman, it's been a pleasure having you here, and I think this is so useful for the listeners that we have learned so much. So I want to thank you for taking the time to come into Let's Talk Micro.
Yeah, well, thank you so much for having me. This has been a lot of fun, and I hope it was helpful to your listeners as well.
Definitely. My pleasure. And that, my dear audience, it's the end of this episode. I hope you enjoy listening to both parts, part 1 and part 2 of this series about discrepancies between genotypic and phenotypic testing. As always, I enjoy bringing this information to you. So please continue bringing that passion to what you do. It's so important. It will make you better at what you do, and such a great job we have. So thank you for listening. Good things coming your way. As always, stay motivated, stay safe, and of course, continue talking micro. Until the next time. Bye.